Have you ever taken a bottle of cold water out of the fridge and noticed tiny droplets forming on its outer surface? Or seen sparkling water drops on grass and leaves early in the morning? Where do these water droplets come from? Is the bottle leaking? Actually, no. You have witnessed dew formation, and to understand it, we need to learn about humidity and dew point. Let's talk about moisture in air. About 71% of Earth's surface is covered with water. Because of this, evaporation is happening all the time. So, water vapor is always present in the air around us. This presence of water vapor in the air makes it moist, and this moisture in the atmosphere is called humidity. Humidity is the moisture in the air, that is, presence of water, right? The amount of water vapor in the air helps us understand the state of daily weather, whether it feels dry or sticky, pleasant or uncomfortable. Now, air can hold only a certain amount of water vapor at a given temperature. If this limit is crossed, the extra vapor condenses into tiny water droplets. So, when the air contains the maximum possible water vapor at a given temperature, we say the air is saturated. If it is less than the limit, we call it unsaturated. Now imagine we slowly cool down a sample of unsaturated air. Alright? As the temperature decreases, the air can hold less and less vapor. At a certain temperature, the air becomes saturated, and any further cooling makes the water vapor condense into droplets. As you see here, the temperature decreases and it condenses into droplets. Water vapor condenses into droplets. This temperature is called dew point. Dew point is the temperature at which air becomes saturated and water vapor starts to condense. That's why when warm, moist air touches the cold surface of a bottle or cold leaves in the morning, as you see here, it cools down to its dew point and water droplets form. Now, to measure how much water vapor is actually present in the air, we use a quantity called absolute humidity. It is the mass of the water vapor per unit volume of air, and it is measured in kilograms per cubic meter. That is how much mass of water vapor is present in a given volume of water. So, absolute humidity is equal to mass of the vapor divided by volume of air in kilogram per meter cube. But wait, hey, the way we feel humidity doesn't depend on how much water vapor is in the air. It depends on how close the air is to being saturated, and that brings us to relative humidity. Relative humidity is the ratio of actual mass of water in the air to mass of the water vapor needed to saturate the air at that temperature multiplied by 100. When the relative humidity is 100%, the air is at its dew point and it's fully saturated. If it's more than 60%, we feel the air as humid. We start sweating. If it is less than 60%, we say the air feels dry. Our throat starts feel drying. Right? Now, during winter, you might have noticed a white trail behind an airplane flying in the clear sky. That's actually water vapor from the plane's engine condensing into clouds. If the surrounding air already has high relative humidity, this white trail takes a long time to disappear because the air is nearly saturated. But if the air is dry, the trail fades away quickly. Now, let's summarize all this by connecting everything. Humidity tells us how much moisture is in the air. Absolute humidity measures the total vapor present in the air. Relative humidity compares how close the air is to saturation. And dew point tells us the temperature at which condensation begins. Together, these ideas explain everyday wonders like from morning dew on the grass to the mist on the windows, even the jet trails in the sky. So, next time you see droplets on the cold bottle or early morning dew on the plants, remember you're actually watching condensation at work. You can think of other examples around you where dew point and humidity play a role.